Hey guys, today we're going to talk about independent versus dependent events in regard to probability. Let's talk a little vocab first. Independent events, they do not rely on anything else. They are not affected by what happens before. Whereas dependent events do rely on what came before, and they are affected by prior events. So that's going to be important as we go forward. Let's talk first, though, about multiple independent events. And we've been studying independent events when we've been drawing cards and rolling dice. We're just doing it one time. Well, now we're combining things a little bit. So, for example, what is the probability of flipping two heads on a coin in a row? Well, we look at our possible outcomes, and I made a little chart here to kind of show us what our outcomes could look like. Our first throw, we could have a heads or a tails. On our second throw, if we threw a heads first, we could also have a heads or a tails. And if we get a heads first and we get a heads second, we would have one success. But if we threw a tails first, we could also get a heads or a tail. So we have 1, 2, 3, 4 total possible outcomes, but only one success. So in this case, the probability would be 1/4. Our next example, what is the probability of flipping a tail on a coin and rolling an odd number on a standard die? Okay, so again, I set up a chart for this so we can kind of see what the outcomes are. So again, if we flip the coin, we could get a heads or we could get a tails. If we get a heads and we roll the die, we can still get a 1, 2, 3, 4, 5, and 6. However, we weren't looking for a heads on a coin, so these would not be successes. If we flip the tail, okay, that would be one success out of two possibilities, so we're already doing pretty well. And then we roll our die. If we roll a 1, it's a success. A 2 is a failure, 3 is a success, 4 is a failure, 5 is a success, and a 6 would be a failure. So these two events, they do not rely upon one another, okay? The coin flip is not affecting how the die is going to roll. It's still going to roll whatever number is going to come up. So we have 1, 2, 3 successes out of a possible 6 opportunities. So we have 1/2 for our coin flip and 3/6 or 1/2 for our rolling an odd number. And what we're going to actually end up doing is we're going to take the 1/2 and take the 3/6, and we're going to multiply those fractions. So 1 times 3 is 3, 2 times 6 is 12, and we now have 3/12, which we can reduce down to 1 success for every 4 attempts. So again, we're looking at situations where one event is not affecting the outcome of the other. And so we have this example where we have what is the probability of pulling an ace from a standard deck of cards and rolling a 4 on a standard die. Okay, so again, whatever I pull from the card deck is not going to affect my die roll. Whatever I roll on my dice is not going to affect what I pull out of my card deck. So we might possibly not succeed, but nothing is going to actually affect the other. So for example, on our card pull, we have 4 aces out of 52 cards, which we can reduce down to a 1 in 13 chance of doing that. On our die roll, to roll a 4, we have 1 success. There's only 1 4 on a standard die out of 6 possibilities. So we can take our two fractions of 1/13 and multiply that by 1/6. Okay, and then we would end up with 1 success out of 78 possible outcomes. So again, these events are not affecting one another. What about when events do affect one another? What would that look like? Well, with this example, we're trying to draw a king from a standard deck of cards, not replacing it. So we're going to take that card, we get a king, we're going to put it on the counter and try to draw again from the deck, okay, to get another king. So again, we look at our cards. On the first draw, I have 4 kings out of 52 cards, which would be a 1 in 13 probability. And if we look here at our next draw, we have only 3 kings left and only 51 cards. Why do we only have 3 kings and 51 cards? Because we've already drawn a king. We've already had a success. Okay? And so we don't need to, the king is out of the deck. Okay, so we now have 1 less king. We also have 1 less total cards. So we now have only 51 cards. So if we look down here, and I need to make a little adjustment, this should be 51. And down here, this should be 663. Okay? When we multiply, we're going to take 1 and 1/13 and multiply that by 3 over 51. So we'd end up with 3 successes out of 663 tries. So we're not really going to have that succeed quite often. All right, and then in this next example, in a class of 10 students, what is the probability of Khalil and Morgan being chosen as either class president or vice president? Okay, so there are a total of 10 people, 10 possible outcomes. Only 2 of them are the people we want. So we have Khalil and we have Morgan. So we can reduce that probability down to 1/5. And then, so presuming that one of them is chosen for president, okay, then we have 1 less person to count as a success. We also have 1 less person to draw from in the class, okay? Because the person who is president cannot also be vice president. So we would take our 1/5 fraction, multiply that by 1/9, and we would get 1 success out of 45 total trials. Again, so the event beforehand affected the event after. So choice 2 was affected by what happened with choice 1. Okay? All right, we will definitely be practicing this in class, and I will see you there. Oos!